Hello everyone! Welcome to another video in our civil engineering refresher and review. So for this video, the featured topic is symmetrical vertical curve, the parabolic curve in surveying. So vertical curves, which is a parabola, is used to provide a smooth transition between two different grade lines. So there are two types. We have the symmetrical parabolic curve and the second, which will be treated in the next video, is about the unsymmetrical parabolic curve. Okay, so symmetrical parabolic curve is made if there is no restriction in the length and elevations of the PC and the PT of the vertical curve. So let us say we consider two grade lines here, G1, and we have here G2. So we connect them by a parabolic curve, a vertical curve. No? So the parabolic curve start at the PVC. So point of the vertical curve, and then we have the PVT, point of vertical tangency. Then the two tangents intersect at PVI. Now, so we have the total length from PVC to PVT of the vertical curve. Then half of that, we have L over 2, L over 2. So we can say that the vertical curve here is symmetrical. No? Okay. So G1 is called the back tangent containing the PVC, and G2 is the forward tangent containing the PVT. So we have here the chord length connecting PVC and PVT. Then we have here the center offset H. This is the distance from the PVI to the curve. So this is distance H also, now by property of parabola. So the formula for the center offset H is equal to L over 8 G1 minus G2. So this is when G1 is positive and G2 is negative. Or we can have also L over 8 G2 minus G1 in the case of a sag curve. By the way, we call this a summit curve. No? So the other one, when we have negative G1 and positive G2, so we call it a sag curve. Then, if you take any point on the parabolic curve, we have a distance x from the PVC. We have this distance y also. So the offset distance from the given tangent with grade G1 to the curve. And y here can be solved by the squared property of the parabola. No? So y over x squared equal to h over L over 2 square. Then we have here the location of the highest point on the curve from PC. So if this is the PC, then we can have the location of the highest point on the curve. So let us say S1. So this is S1 equal to G1L over G1 minus G2. This is the same formula if you have a sag curve na. But in our figure, we have a summit curve. So we have also the location S2, now the distance of the highest point from the PVT. So S2 is G2L over G2 minus G1. Then we can have also the equivalent radius of the curve, assuming that this is a simple curve. No, actually this is a parabola, but for shallow slopes of G1 and G2, then this will turn out to be fitted in a circle. And assuming this to be a circle, we can have the radius r of the circular curve, no? L over G1 minus G2, where G1 and G2 are in percent. Then we have the length of the curve for every 1% change of the slope. Na? So, length of the curve for every 1% change. So, this is G1, then it will change to G2. Na? So, the length K there is L over G1 minus G2. If you compare, that is the same as R. But in number 6, our G1 and G2 are in decimals. Okay? So we can now have problems. So problem number 1. A parabolic curve has a length of 300 meters. It has an initial grades and final grades of plus 4% and negative 2% respectively. The elevation of the PVC is 42 meters and at station 8 plus 320. Compute the vertical distance from the PVI to the curve. Then find the stationing of the highest point on the curve. Find the elevation of the highest point on the curve. Okay. So we can draw the curve na. So we have G1 plus 4%. Then we have G2 negative 2%. So this is a summit curve na. Then PVC, and then we have here PVT. So the length of the curve is 300. So this is PI. The length here from PVC to PVT is 300. Half of that, because this is symmetrical. By the way, if not stated now, and if there is no restriction on the location of the PVC and the PVI, no? So the curve that can be laid out there is symmetrical. Na? In the next video, we can see the difference if there is a restriction on the location of the PVC and PVT. Na? The curve is unsymmetrical. Na? Okay. So, the first question is the vertical distance from PVI to the curve. So, PVI to the curve, this is distance h. Na? And we have a formula for h. So, to solve for h, we have L over 8 G1 minus G2. So, 300 over 8, 0.04 minus negative 0.02. So, h is 2.25 meters. We can check na. So, 300 over 8, then we have 0.04 minus negative 0.02. So, that is 2.25 meters. Okay. So, the second question is the location of the highest point on the curve from the PVC. So, that is S1, ha? So, we are given the formula G1L over G1 minus G2. So, 0.04 times 300, then over 0.04 minus negative 0.02. So, 0.04 times 300 over 0.04 minus negative 0.02. And that will give us 200 meters. Okay. So, the station of the PVC is obtained by adding the station of the PVC to the highest point na. So, station of the highest point, that is the PVC 8 plus 320 plus the length 200. By the way, the length of the curve is assumed to be the horizontal na distance from PVC to PVT, not the curve length na. Okay, so we have here 8 plus 520. The third question is the elevation of the highest point. So, in the figure, this is 50, na? Okay. So, I can solve for the elevation of the PI. So, this is elevation 42. I have grade 0.04 or 4% times a distance of 150. So, the elevation of the PI is 42 plus 0.04 times 150, and that is equal to 48. Then, I can subtract this distance na. Okay. By the way, this is S1, this is 200 na. So this is 100. So this is 50. So I can solve for the elevation of the highest point on the curve by subtracting the two distances. First, I will solve for y now. So by squared property, y over x squared equal to h over L over 2. But we refer this from the PVT na. Y over x equal to h over L over 2. So y there is 1 meter. Then if I will call this distance h, the yellow distance na. So the elevation of the highest point is elevation of PVI minus h minus y. Where h there is equal to the grade 0.02 times the distance 50 na. So the difference in elevation from PVI to the tangent at this point here. Okay, so elevation of the highest point is elevation PI 48 minus y, which is 1. Then this is 0.02 times the distance 50. So that is at 46 meters. Okay, so this is a vertical summit curve na. Okay, so the next problem here is about vertical sag curve. So we have here a descending grade of 6% intersect an ascending grade of 2% at station 12 plus 442 of elevation 18.6 meters. These two grade lines are to be connected by a 160 meter vertical parabolic curve. Find the distance from PBC to the lowest point on the curve. Then number 2, what is the elevation of the first quarter point on the curve? And number 3, what is the elevation of the lowest point on the curve? Okay. So, I have a descending grade, 6%. So, negative 6% na. Then, meet an ascending grade of positive 2%. And then, elevation and station of PVI na. So, they meet or intersect at the PVI. So, this is the PVI here. This is at station 12 plus 442 and elevation 18.6. Then, the length of the parabolic curve is 160. So, we have the PVC, then we have the PVT. Connect by parabolic curve. So, this is 80. This is also 80. Total length 160. Okay. So, find the distance from PVC to the lowest point on the curve. This is S1. Okay. So, this is the lowest point on the curve. So, by formula, S1 is G1L over G1 minus G2. So, if we substitute, we have 120 meters. Second, elevation of the first quarter point on the curve. So, the length of the curve is 160. I can take or divide this by 4 na. And I have the first quarter point from the PVC. So, ito yan. So, this is the first quarter point na. Half of 80. So, 40, 80, 120, and then we have 160. Okay. So, I have H already. I have solved H already. That is 160 from the first na. Then, I have here Y. Then, distance 40. So, for the elevation, I can solve for Y over X squared equal to H over L over 2 squared. When X is 40, Y is 0.4. So, the elevation of the first quarter point so is the sum na PVI elevation, which is 18.6 plus this red distance vertical plus the Y na. So, elevation, this is not the lowest point ha. I will just erase this dali ha. First quarter point na. So this is elevation of the first quarter point. So first quarter. So elevation of the first quarter point. So in the figure, that is equal to 18.6 plus 0.06 times 40 plus y, which is 0.4. So that is 21.4 meters. Okay, so erase nyo lang to. Elevation of the first quarter point na. Talagang may mga mali ng konti sa ano, no? Okay, so we have here. So the elevation is 21.4, no? So elevation of the first quarter point. Okay, the third question is the elevation of the lowest point on the curve. So same as what we did, no? We locate. Now we have located already. Then solve for h. We have these values already. Solve for the y here. And by proportion, y over x squared equal to h over L over 2. The x here is this distance, na? Because we have h over L over 2 equal to y over x squared. So substituting values when x is 40, that is also 0.4. So I can have this distance. This is the grade 0.02 times 40. So the elevation of the lowest point is 18.6 plus 0.02 times 40 plus 0.4. That is 19.8 meters. Okay, so for this video, the topic is about symmetrical parabolic curve. So just take note of the formulas. Some are not formulas. We can just solve it by using the grade lines, the distances, in order to solve for the elevation. Okay. So thank you very much for viewing this video. Till the next video. So the next video here will be about unsymmetrical parabolic curve. Thank you.